All right, so my name is Elizabeth Davis. I'm an NX application engineer with Applied CAX. And I'm going to be talking about feature-based machining inside of NX CAM. Can I get a show of hands of the CAM users here? How many of you have used feature-based machining? I saw about 3 guys besides our people. Okay. So I'm going to start off with an intro to feature-based machining, and I'm going to give you kind of a scenario of when you would use it and when it would be most beneficial. And then I'm going to talk a little bit about traditional programming versus feature-based machining program, get into some of the areas where it's been implemented and some of the coverage of feature-based. Then we're going to watch a couple of demos, and we're going to talk a little bit about if you're just getting started with feature-based machining, how you can analyze your parts for the features that you can take advantage of and use feature-based machining. So an example of when feature-based machining would be particularly helpful is, say, a counterbore feature, counterbore hole. If you're a CAM programmer, there are a lot of different ways, a lot of different operations, geometries that you would use to create that feature or to machine it. You have drilling, boring, helical milling, spiral milling, circle milling, circular. Depending on your machine, you might have different speeds and feeds you'd use. Depending on your material, that would also change your parameters. If you've done it before, how would you do it again in the future? What would you change if your material changed? And it goes on and on and on. And if you had to do 10,000 holes a month, that gets very repetitive. And that is, Siemens wanted to try to capture some of that information for reuse. And that's what we're going to get into with feature-based. And then even further, like if you asked 5 different NC programmers how you would machine a counterbore, you'd probably get 5 different answers and just as many reasons for why it was that way. So what is feature-based? Feature-based machining is a generative technology that automatically determines the machining process for a wide range of features. It's built off of a set of rules and conditions called Machining Knowledge Library. That information is contained in an XML file. It is then accessed by NX and used to analyze your features to generate the machining process, which is determined by a set of rules and conditions. What I mean by machining feature is any shape that is recognizable by the software as machinable, i.e. holes, slots, pockets, or something custom. And I'll talk briefly about how to teach NX to recognize a custom feature. So in NX, there are, can you see my mouse? No, you can't. So out of the box NX CAM, there's over 100 recognizable features. Holes, slots, pockets, planar surfaces that you can take advantage of out of the box. And the Machining Knowledge Editor is a tool that you can use to customize that machining knowledge library. It does require an author license to edit it though, but there's still a lot that you can do with the out-of-the-box features. So let's talk a little bit about traditional manual programming versus the feature-based machining programming. So the traditional workflow is you define your workpiece, you create your operation, select your geometry, your tool, your feeds and speeds, and then add any UDEs if you want. Then you create operations 2, 3, 4, 5, and however many. And then you're probably going to repeat that a little bit and go through a couple of iterations. Then you finally get to simulation and verification and post-processing. With automatic feature-based machining steps, so first step is the same. You're going to define your workpiece. But then using the feature-based tools, you can find your features. You're going to automatically create your operations, generate those tool paths. And then if you need to change anything, you can go in and edit as normal. You can change the operations, add another operations, change out the tool, you have full control over whatever it's created. Then you can simulate, verify, and post-process. So let's take a look at the kind of scope of where feature-based machining operates. It's traditionally been majority of 2.5D prismatic machining, mostly whole features, but it does have, and industry, it doesn't matter, it could be automotive, aerospace, machine, prismatic parts, plate parts, doesn't matter, turning and wire EDM as well. So it also covers, thread milling, planar milling, cavity, plunge, Z-mill, or Z-level. So it covers a wide variety of operation types and operation features. So this is NX 1847, NX CAM, and if you're a CAM user, you can see that pretty well. If you're a CAM user, the Operation Navigator is going to look really familiar to you. So right now we don't have any programs or any operations in here. And I've set up my geometry, my workpiece, and G54 is down here in this corner. So this is the Machining Feature Navigator. It's right below the Operation Navigator. And in this tab, if you want to start finding features, so I'm going to talk about real quick what we're about to do. First, this is our part. We've set up our setup file. We're going to find our features, then we're going to create our operations, and then we're going to generate them. So right-click in the Machining Feature Navigator, come down to this Find Features right here. And this is the Find Features dialog. In here you have a couple of different recognition types that you can use. Usually you're going to start off with parametric recognition, and you can select which geometry you want to search. Usually you're going to have this set to workpiece. Specify as another one that you might want to use if you have multiple geometries. Features to recognize. This is where you're going to select what feature type you want to recognize. And it's a big dialog, so I'm going to make it bigger. So in here, these are all the types out of the box that NX can recognize. There's bosses, corner notches, grooves, holes, pockets, side notches, slots, steps, and then we've got a couple turning and weld EDM features. With our part right here, it's got a lot of holes, so something to note is if you're getting into feature-based machining and you have hole features that you want to find, you're actually going to check steps. And a lot of these features have hole in the feature name. They are steps. Holes will find a different type of feature. It's a little bit confusing. So we're going to check steps. And then you can select the direction that you want the features to be found in, like the tool direction. So then once you've set it up, you just click this button right here for Find Features. You can take a look at all of the different features that it's found. And what's been found is highlighting in red. Can you see that? Yeah. Then just click OK. And your identified features are going to show up over here in the Machining Feature Navigator. And then if you drag this over, you can take a look at all the feature parameters right here that are being used. This is what NX is going to use to determine the operation parameters. So from here, just right click, and then you're going to say Create Feature Process. And what this is going to do is it's going to take a look at your machining rules, compare that with these feature parameters, and determine the best way to machine your parts. So we aren't doing any turning or EDM work, so mill drill is fine. Set this to automatic, use existing, and you're going to want this type up here set to rule-based, and go ahead and click OK. and you go pour yourself a cup of coffee. All right, let's go back to the Operation Navigator. So now it's created all of these feature or these program groups. We've got spot drills, taps. We even got a deburr operation. So from here, we can generate it this we want to, but I'm going to move over to a different demo. So here we have a prismatic part. And here, this is our workpiece. So here's our workpiece. There's our blank. This is a cast part. There is actually some positive material. It's just hard to see. And there's our check geometry. So in here, and G54 is right there. So again, we're just going to say find features. I only want to find this one type right here. I'm going to uncheck recognition. I'm going to find features. So it's found 3 planar surfaces, these 3 right here. And then I think I'm also going to find, we're going to find steps and slots. So let's take a look at what it's found. This we don't need to clean that face right there. Same thing with this feature under here. So we can get rid of that and go ahead and click OK. So now we're going to right click again, say create feature process just like last time. Imagine how long it would take if you had to do this by hand. And that only took about 10 seconds. So we go ahead and generate this. Then I'm going to show you how you can edit your rules using the teach operation sets. And an example for when you might want to do that is if you have core tooling that you would like to automatically be selected as opposed to something from from the NX's library. So right here, take a look at this U-shaped pocket right here. We're roughing it with one tool, and then we're finishing both the floor and the wall with the same tool. Now, if I want to change this and tell it to select a smaller tool, because I usually like to finish with a smaller tool, we can go into this feature, and this is called a teach part. And I'll talk a little bit more about teach parts in a couple of minutes, but this is how you're going to make that change. So right click on your feature group or your geometry group, go down to object, and then teach operation sets right here. And then when you go ahead and open this up, the teach operation set dialog is here, and on the left hand side it shows your operation sets, and then to the right you have the parameters. You can see. You have the objects right here that create this operation. So you've got the feature itself, you have the operation parameters, and then you have your tool parameters. And to the right it shows all of those parameters. And for the operation, you can see that you have the ability to take advantage and leverage all of these parameters. So from tool step over, your engage, your retract. You can drive all of this through these machining conditions. So right down here, so first right here, these operators are going to help you build your condition statements, and this is where you'd edit it. So this is what I want to edit right here. So this is controlling and determining the tool diameter that gets selected. Right now this says tool diameter must be less than or equal to the feature radius times 2. But I want a smaller radius selected, so I'm actually going to subtract 5 from this value. So then what I did was you click this check mark and that verifies your statement, and then you click this hat down here and that teaches it. So this is your teaching machining rule. And I did that to the roughing and not the finishing. So here, I'm going to edit this real quick. Okay, so I wanted to make the change for the finishing ops. And if I make a typo like I just did, it's going to catch it. And then I can fix it and then check it and teach. So now we can go back to our part, and I'm going to open up these geometries. So this is what I wanted to redo right here. So I'm actually just going to delete this. And under the machining feature navigator, because I already found this feature, all I have to do is say create feature process again. I don't have to find it a second time. And this time it's selected a smaller tool. Let's see. We could even verify this. And like all of this we did through the feature-based machining. We haven't created any new operations ourselves. We didn't select any tools except for through the machining rule that we just edited. Oh, that's slow. And then you can do the same kind of thing with plate parts. We've got 2 ejector plates right here. Very similar. They're different parts, but they do share a lot of the same features. You can again take advantage of the machining rules and use feature-based machining to program these parts. And it was able to recognize pretty much everything on here. We could do the same thing with this part. Oh, I'd already found them before. So let's go back to the PowerPoint. So that was the first demo. We saw all of the out-of-the-box features that you have access to, and we saw how quickly you can find your features and create your operations. And then we saw the prismatic example, And then we saw the plate parts, and plate parts share a lot of, they have a lot of holes and pockets usually, and you can take advantage of that information. So next we're going to talk about how to analyze your part if you're looking into feature-based machining. So right here is just kind of a flow chart of the process that you would go to for deciding the best way to handle this for your features. So first, is it an out-of-the-box feature? If no, then you do have teach functions available to you. You could teach a feature which teaches NX to recognize features that are maybe unique to your industry. You can also change using teach feature mapping, you're able to change the out-of-the-box names. So if the step names are confusing for you, or if you just have specific names for your features, you can use that to change that to make it a little more user-friendly for you. And the recommended method for going about this is taking a look at all of your parts that you work on, running some parametric feature recognition, exporting that data to really get a good look of just the typical features that you work with. Like it says at the bottom, 80% of all your features are represented by just a couple of feature types. So this is kind of the method of how machining knowledge definition works. So you have one machining knowledge editor user who takes all that machining knowledge that you collected from all of your parts, creates the machining knowledge, and then that can then be used and harnessed by all of your NXCAM users. So the teach operation sets is what we did to edit that diameter, the tool diameter rule. For new users, that is going to be the method that's going to be best for a newer user. For a more advanced user, the machining knowledge editor is a tool that you would use. So the machining knowledge editor is a very powerful tool, but Siemens recognized that it does actually have a couple of drawbacks. The main one being that it is an external tool to NX, so you actually need to leave NX and go work in another tool. And a lot of users, they just didn't like that. They wanted to work inside NXCAM. And so the teach operation sets is within NXCAM, and it is much more user-friendly, and it has a lot more advantages. So Siemens recognized that, and they're doing a lot of work to improve it and bring that functionality from the machining knowledge editor and keeping it in the NXCAM environment. So the teach part that I was talking about, this is the approach that you would want to take. This is what Siemens recommends for how to keep all of that information for your feature types in one place. So once you identify a feature type and then you identify the different variations of that feature type, you create it in this teach feature part, kind of like what's shown up here. And then so not only does it contain the feature definition, it's going to hold the operations, the machining process that you've identified as your best practice. And then all of that information remains in one place. And that's really good. So in the future, if you decide to, as you go through iterations and you update and improve your process, you go back to this part and it's all in one place, and then you can update it here, and then it all stays together. So basic idea behind the machining rule is that you're connecting your parameter or your feature parameters and using that to drive tool selection and operation parameter selection. So a question that comes up a lot is, can I set feeds and speeds through feature-based machining? And the answer is yes. It is possible to write a machining rule through an FBM rule. That's really not recommended. Siemens prefers that you use machining data library to drive your feeds and speeds. But once that is set up, it will work with your feature-based machining. So what I hope you take away from this presentation is the power of feature-based machining, and that is a great time saver for you. And it reduces mistakes. It removes a lot of repetitive tasks in your programming, and then your programmers can spend more time focused on those critical features that are more important and honestly more fun to focus on. And it also brings about your standard process. And with the standard process, that does have this added benefit of removing process variability. So I hope you're all excited to go try out feature-based machining. Thank you.